Lesson 2-5. Get your notebook set up properly. There are only 2 vocabulary words, and one of them doesn't even count as a vocabulary word. You know this one. But a literal equation is an equation that has 2 or more variables. That is not very easy to read, especially with the scribble there. That says an equation with 2 or more variables. Then a formula, you know what that is, but a formula is a special type of literal equation. The next step in our process is realizing that all of these tricks that you have learned, I shouldn't say tricks, all of these techniques that you have learned to deal with manipulating equations still count even if it's not a constant. Take a look at problem 1. There we go. You have a literal equation with 2 variables, 10x plus 5y equals 80. And they give you a couple of values for x, 3 and 6, and they want you to figure out what y is going to be. The first step that they want you to do is simplify this equation by solving it for y. So if 10x plus 5y equals 80, first thing you can do is get 10x on the other side of the equal sign. Isolate the y term. So 5y is going to equal 80 minus 10x. Then divide each side by 5. You've isolated y. Y is equal to 16 minus 2x. Now you can use this simplified equation and plug in the number 3 that they gave you. Y equals 16 minus 2 times 3. If x is equal to 3, y is equal to 10. On the other hand, if x is equal to 6, y is equal to 4. So in other words, I know Tyler's going to use this formula somewhere. If you buy 3 pizzas, you can buy 10 sandwiches. If you buy 6 pizzas, you can buy 4 sandwiches. And of course, really, why would you buy sandwiches at all if you can buy pizza? Problem 1, the A part, is this equation, 4 equals 2m minus 5n. It's another literal equation because it has 2 variables in it. They want you to solve the equation for m, which is why I circled m so that I could remember what I was trying to do. That's your first step. So I decided to add 5n to each side. And you'll notice that I put a star here because this I expect to see in everybody's work. 4 plus 5n equals 2m. Divide each side by 2. And you either end up with 4 halves plus 5n halves equals m, or this one, 4 plus 5n over 2 equals m. These are equivalent. This is something that we worked on in the last unit. So now that we've solved for m, they want you to know what m is equal to when n is equal to -2, to 0, and to 2. So take a look at how I labeled my notebook here. If n is equal to 2, and there's a column underneath here. If n is equal to 0, and another column here. If n is equal to +2, and another column there. Gotta keep these things neat so I can figure out what your math is. So since I wrote n is equal to -2 under this one, I'm going to substitute it in this one. And I put a star here because I must see this step. 4 halves plus 5 times -2 over 2 equals m. Simplify. This becomes 2. This becomes -10 over 2, still equal to m. Simplify again. 2 plus -5 equals m, and this is a step that I should see. Your solution is m is -3. The next problem, if n is equal to 0, then, and since I wrote that under this one, I'm going to use this one this time. You have 4 plus 5 times 0 over 2 equals m. I should see this step in everyone's work. Again, I should see this step. 4 halves equals m equals 2. And last but not least, if n is equal to 2, then 4 plus 5 times 2 over 2 equals m. 4 plus 10 over 2 equals m. 14 over 2 equals m. 7 is equal to m. And again, no shortcuts here. I should see all those steps. For letter B, number 2, I want you to do that on your own. Go back to problem 1 and substitute x equals 3 into the equation before you solve the equation for y. And then think about which one you prefer. Take a look. It's got it, number 1, letter B, top of page 110. Follow the directions. You go ahead and do that. I'll wait. So you should have come up with the exact same answers as they had in the example for that last problem. The only difference is which way did you prefer to solve it. I suspect the way they did it in the book the first time was a little easier. I think it was probably harder to substitute x in before you had simplified the equation. We are moving on to number 2. And this one is kind of interesting. An equation with only variables. Look at this. ax minus bx equals c. Currently, it is solved for c. They want you to solve it for x. Well, it's no big deal. You're going to use all the skills that you've been using right along. Write your equation just as it is, and then, using the distributive property. This is called factoring out the x. Factor out the x. You still have a minus b equals c. Now that we have x somewhat separated, what are we going to do to get it completely isolated? We are going to divide each side by a minus b. So x is equal to c over a minus b. It's a little ugly, but that's all there is to it. It wasn't complicated. You know all those laws already. Got it, number 2. What equation do you get when you solve the opposite of t equals r plus px for x? I know you can't wait for the answer. So very straightforward. First step, you must write the original equation in. We are solving for x, so I think I'll go ahead and circle that so that I can remember what we're doing. First step, what's going to be easiest? That is right, Willow. We need to subtract an r from each side. So the opposite of t minus r equals r plus px minus r. So now we have t minus r equals px. Then we need to divide each side by x. And then I ran out of room on my notebook. I can't write below any farther. So what I did was I went to the side. There's my answer, and I circled it to make it super clear that that's what I was getting at. Not too complicated. I know you guys can do that. So why, you might ask, would you ever have to rearrange an equation with only variables in it? Well, I'll show you. The bottom of page 110 has a bunch of formulas in it. Some of them you already know and love. Some of them you will come to love soon. I believe that perimeter, circumference, area of a rectangle, and triangle and circle are all old news to you guys. Distance traveled might be new. Distance equals rate times time. Temperature, I know you have converted from Celsius to Fahrenheit. This is the formula that people use for that. You don't have to have these all memorized at the moment. They are just here because you need them for some of these other problems. Go to the top of page 111. What is the radius of a circle with a circumference of 64 feet? Round to the nearest tenth, and they give you an exact value to use for pi. So your first step, you must write the formula you're using. It's so easy. Don't goof it up. Then, how are you going to simplify it? Well, divide each side by 2 pi. Then, this is what you have. Circumference over 2 pi equals the radius. Then put in what you know. Well, 64 divided by 2 pi equals r. And then using our value of 3.14, you end up with 10.2 is approximately the radius of this circle. Got it, number 3. What is the height of a triangle that has an area of 24 inches squared and a base with a length of 8 inches? Well, grab your notebook. Let's figure it out. So first step for number 3, write out your formula. Area, and that's a small triangle. Area of a triangle is equal to 1/2 base times height. Then I solved this a little bit differently than they've been modeling in the book. I'm going to actually show you both ways. It seemed pretty straightforward to me just to plug in the numbers we know. We have that the area is 24 and we know that the base is 8. So I put in 24 equals 1/2 times 8 times the height, which gives us 24 equals 4 times h, divide each side by 4, 6 is equal to the height. If you want to follow exactly what they did in the book, which is a fine way to do it, this time it works out to be a little bit long, but that's okay. We know that area equals 1/2 base times height. Their way is to isolate the variable that you're looking for first. So to do that, we're looking for height. We need to divide each side by 1/2 base so we can get that isolated. So then we end up with area over 1/2 base equals height. Put in the numbers that we know. The area is 1/2 times 8, which equals 8h. 24 over 4 equals h, and that's going to be equal to 6. Same exact answer, two ways to do it. Either way is correct. Problem 4, same idea, except instead of geometry, it's, butterflies. So they give you some numbers concerning a butterfly trip, and check this out. It takes a butterfly 120 days to travel one way. How far does it fly in miles per day? And you work through this, 14 miles in a day. That little tiny thing flies 14 miles a day. I'm not sure that I could walk 14 miles every day for 120 days, and I'm a whole lot bigger than a butterfly. So anyway, I skipped through that. Go ahead and read it carefully. And then got it number 4 involves gray whales. They migrate annually from Alaska to Southern California and back. They go 5,000 miles each way. It's 91 miles a day. How many days does it take the whales to migrate one way? First question you have is, what formula do I need? Oh, look, it's the same one they used in the example. This is the distance formula. Distance equals rate times time. So take your notebook. Where's mine? Where's my notebook? There we go. Distance equals rate times time. And again, I just substituted the numbers in directly. We know that they're going 5,000 miles. We know that their rate is 91 miles a day. Divide each side by 91. And it takes them approximately 55 days to make that trip. And that is the end of this unit. Your homework, the rest of your homework, is page 112, number 11 through 35, odd. Just get some extra practice manipulating equations that have only variables and two variables. Great!